This is lesson 7.5, a tangent ratio. So the first thing we're going to talk about is the sides of a right triangle. We know in a right triangle we have two legs and a hypotenuse. So just to distinguish between the two legs, when we go from a given angle, say in this case angle A, when you go across the triangle to that leg, we're going to go ahead and call that the opposite side, the opposite leg. The one that's beside it is what we call the adjacent leg. And of course, the hypotenuse is still the hypotenuse. Now, if we go from the other acute angle, you're always going from one of the acute angles. If you go from the other acute angle, this one now becomes the opposite. And this one now becomes the adjacent. So it depends on which of the two acute angles you're going from. So the first ratio we want to talk about, we're going to compare the lengths of the two sides. It's called tangent. And tangent from angle A, in this case, is the opposite leg over the adjacent leg. So let's just practice using the opposite and adjacent legs. So they're asking us to find tangent from angle A, and then we'll find tangent from angle B. So starting with angle A, we said tangent is the opposite side over the adjacent side. So from angle A, opposite is 24. So tangent from angle A is 24 over the adjacent side, which is right here, over 7. Not this one. This one's the hypotenuse. We're not using that. Now, if we look for tangent from angle B, from angle B, 7 is now the opposite, and the 24 is now the adjacent. Okay, let's do it one more time. From angle A, opposite, so tangent from angle A is opposite, which is 35, over adjacent, which is 12. Now if we look from the other direction, tangent from angle B, opposite now becomes the 12, and the adjacent becomes the 35. The 37 is still the hypotenuse. We're not using that right now. So why are we studying the lengths of the sides, or the relationship between the lengths of the side? That's called trigonometry. And trigonometry is the study of the relationship between the angles and the sides of a triangle. And a mathematician figured out that there's a relationship between the sides of a triangle for every given angle. And that mathematician created a chart for each angle, what the relationship, what the ratio of the sides should be. And we, of course, took that chart and put it into our calculators. So the first one we talk about is called tangent. We've been practicing that. Tangent is opposite over adjacent. We're not going to deal with the hypotenuse yet. So now we're going to throw, instead of calling that angle A, we're going to put a number in there. We're going to put 41 degrees. So we're going to say tangent, instead of from angle A, we'll say from 41, tangent of 41 degrees equals, and we know tangent is opposite, so from the opposite we have a 12 over adjacent. Now it becomes interesting. We're going to find our unknown side there. Again, that mathematician figured out the ratio of the sides. We know a ratio is a fraction. Of course, they can turn that fraction into a decimal, so he or she must know that what the relationship is for a 41-degree angle. We're going to use that fact to find the missing side. I like to put my tangent of 41 over 1, so it looks more like a proportion. We're pretty good at solving proportions. That's easy for us. So now we're just going to cross multiply, and we get 12 equals tangent of 41. If you punch that in your calculator, you'll get a decimal, but we don't want to do that yet. It's more accurate if we just leave it as tangent of 41 times x. And we want to solve for x, so let's divide each side by tangent of 41. So you're going to need a calculator at this point. You can certainly use a chart, but that's a lot more work. So let's go ahead and grab our calculators, and we're going to say tangent divided by, and look in the middle of your calculator, you're going to see a TAN button. That's our tangent button. You're going to press 41. Doesn't matter if you close the parenthesis or not. And it's going to tell us that that missing side is 13.8. Pretty amazing, isn't it? So let's try another one. We're going to go tangent from, in this case, 27 is opposite. In this case, our opposite is our x over adjacent, which is 15. Again, I like putting my tangent over 1 just so it looks more like a proportion to me. We're going to cross multiply. X times 1 is x. And again, tangent of 27 times 15. And we're going to just punch that in our calculator. So we're going to use the tangent button, 27. This time you do have to close your parenthesis because we're multiplying times 15. And you're going to get that missing side is about 7.6. We knew it was going to be less than 15. It's a smaller side because it's a smaller angle. So 7.6. Incredible. Okay. One thing you maybe notice is that we could easily find this other missing angle. We know all triangles have 180 degrees. So if we take 90 plus 25, we get 115, take 180 minus 115, we can see our missing angle is 65. So it doesn't matter which of the two acute angles. You never want to go from the right angle. You always want to go from the acute angles. So you can go from the given angle. That's certainly easy enough. So right now, again, all we know is tangent. Tangent of a 25-degree angle equals opposite over adjacent. Cross multiply again. And divide. We want to get x by itself, so we're going to divide each side by tangent of 25. So we're going to punch in our calculator 8 divided by tangent of 25. And that gives us about 17.2. We're going to round to the nearest tenth. Does it tell us to do that? Yep, right there. Okay. And that seems like a reasonable answer. We knew it was going to be bigger than 8. And what the directions are telling us here is find it from the other acute angle. You certainly wouldn't want to do this all the time. It's a lot of work, extra work. But I just want to show you what it looks like. So now I know this angle is 65. We can certainly do tangent from there. So tangent from a 65-degree angle equals opposite, which is now our x, over adjacent, which is now our 8. And we're going to cross multiply again. So we get x equals tangent of 65 times 8. We're going to punch that in our calculator and hope we get the same answer. So we're going to say tangent of 65, close parenthesis, times 8, and it looks like that's about 17.2. Okay, so it works from either of the two acute angles. It doesn't matter which one you choose. So we're going to stop there, and then we're going to add in the other side, the hypotenuse. So go ahead and try the practice problems. Let me know if you have any questions. Thank you.